So remember in the last video, we found the vertical asymptotes by reducing the rational expression right here. Then we set the denominator of that reduced expression equal to 0 and solved it, and that was our two vertical asymptotes. And then when we graphed using the calculator to kind of help ourselves, we were very careful that x equals -2 is this vertical line right here, and we never cross it. You don't put it on the graph, but you don't cross it either on your graph, right? And then x equals 4 is the other one. So you can see my graph kind of approaches 4, but it never crosses it. All right, so now we're going to do that same thing over here with this problem. So we're going to have to reduce first. That's our first step. And the expression is x plus 4 over x squared plus 3x, take away 4. Okay, so I'm going to reduce that. That's my first mission. So this would be equal to x plus 4 over x plus 4 times x minus 1, right? Because that way, if I multiply, for my last, I'll get -4. For my first, I'll get x squared. And then outers and inners. Outers is -1x. Inners is positive 4x. And when you add those up, you'll get 3x in the middle. All right, so what happens here? Well, x plus 4 is in the numerator, and x plus 4 is in the denominator, so they're going to reduce and leave you 1, because when you're dividing, what you're really doing is getting 1. So it's 1 over x minus 1. All right, so now we're reduced. The vertical asymptote, or asymptotes, whichever, will make the denominator equal 0. So we're going to set our denominator equal to 0. So x minus 1 equals 0. This is actually really simple. You'll add 1 to both sides, which means your vertical asymptote oops, I spelled asymptote wrong, would be equal to x equals 1. It's an equation, right? It's a vertical line, so that it has to be x equals a number. All right, so now I have my vertical asymptote, and I'm going to use that to help me graph this problem. So I'm going to graph, and I have a choice. I can either graph x plus 4 over x squared plus 3x minus 4, or I can graph 1 over x minus 1. For our purposes in this course, it's not going to matter too much. So let's go to the calculator. I'm going to clear out this old equation. Alpha f1, hit numerator over denominator, and then I guess I'll just do the, well, I'm going to do the original actually, because I want to explain something to you. So I'm going to hit x plus 4, x plus 4 over 3x squared, what was it? Oh, sorry, x squared plus 3x, my bad. X squared plus 3x, take away 4. Right, okay. So then, when I graph it, I should see 1, there it is. See how 1 becomes that vertical asymptote? And then I can use that to help me graph. Now I want to show you something else real quick, which is, oh, I don't need to have the table set at 0.5s anymore, so let me make these change in table 1. There we go. All right, so when I go to the table, you can see right there at 1 it has an error. That's my asymptote. But there's actually another error. It's right here. See it at -4. And that's because I typed in the original expression. I just wanted to kind of comment to you. See, x plus 4 was in that denominator. See it right there? Before we reduced it down. But because it canceled with the numerator, because it divided away to 1, it didn't make an asymptote. What it does make is kind of a hole. There's actually a puncture in the graph that's so small you can't really see it, but it's there, right? So the graph kind of skips along, kind of hops over that little hole and keeps going, and then heads towards the asymptote over here at 1, which is why you have to be careful. You always want to reduce your fraction first before you find your vertical asymptotes, because if you don't reduce it, you'll think that there's going to be an asymptote at -4. And there isn't, because -4 reduces, right? Because x plus 4 over x plus 4 goes away, and -4 plus 4 is 0. So you have to be very careful to always reduce and use the reduced expression to find your asymptotes, not before. And that's the point of that note right down there. Meantime, you should just copy the graph from your calculator. Make sure that you skim along this x-axis here. You don't want to touch that. And then over here at 1, there's your vertical asymptote. You don't want to cross that. So you kind of get up close, close, close to it, but never cross it. Same thing up here. Get very close to 1, but don't actually cross that stream. All right, now let's do a modeling problem. And then we'll be all done. But unfortunately, it's a long problem. So we have the following table shows the number of households in the U.S. total and the number of households with internet access. So here's the total number of households, period. And there are the number of households with internet access in the U.S. So a good model for the total number of households, this one, is U of t equals 1.30t plus 94.02. And a good model for the number of households, this one, would be 4.37t minus 1.42. Sorry, number of households with internet access, hence the letter I. All right, so I found those models for you when I made these notes, but how could you have done it yourself if you had to? Just a little reminder. So you would have gone to, oops, yeah, I know. Stat, edit, enter, data sets, right? Then you make a scattergram, and then determine from there which model appears best. You find the model and double check that your R squared value is close to 1, or as close to 1 as possible, from the 3 possible models we have so far. That would be linear, exponential, and quadratic. Those are the ones we know. So that's what we learned in chapter 7.7 actually. So you enter your data sets, you make scattergram, and then you determine which model appears best, and then you find and double check your model using your R squared value and your scattergram. Double check that your R squared value is high, that your that your model fits the data, and that your R squared value is close to 1, or as close to 1 as possible of the 3 models that we have. So it's kind of long and involved, right? You got to make a scattergram, you got to see that the curve fits the scattergram, check your R squared value, see that it's high, and so on. Okay, so using the table, so that's from the table right here, from 1997, that's right here. So 1997, what percent of households in the U.S. in 1997 had internet? Okay, well, here's the number with internet, and here's the total number possible. So to make a percent out of that, what would you do? Let's see, percent with internet. That would be the number with internet divided by the total. So let's do that. Number with internet divided by total. Let's see how that works. It's going to be close. So that would be 18.4. 18.4 divided by 102.2. See if I do that right. Yep. Okay. Let's grab the calculator. This isn't quite right, but I'll help you out. So 18.4 divided by 102.2. And that's not quite right, because it isn't 0.18%, it's 18%. So how can we mathematically change it so that it automatically moves the decimal over 2 spots? Well, we can do that by just multiplying by 100. So if we take the number and then we multiply it by 100, that'll work. So then we take this and multiply it by 100, and that'll be 18%. There you go. So that's how to find a percent. You take your number that you're looking at, divide it by your total, and you multiply by 100. All right, so we're going to use that same idea to find an equation for any year, not just 1997. So we're going to take our I of t and we're going to divide it by our U of t. So percent over time would be I of t divided by U of t. So that's internet divided by the total in the US, U for t, U of t for US. But we times it by 100 in order to make it work. So that means the percent of t is equal to, all right, I of t was this value, 4.37. Okay, and then U of t is right here. And you're going to multiply by 100. Now, the easy way to multiply by 100 is to do it this way. Actually, I'm going to put it right over here. You just multiply it because it's really 100 over 1, right? So what you do is you multiply both the numerator values times 100. It's this entire numerator times 100. So you say, okay, that is, actually, I'll put it down here. P of t equals, denominator stays the same because anything times 1 is itself, and the numerator becomes 437t minus 142. So you multiply both values by 100. Make a note. Right? Distribute. You got to multiply both values times 100, and you're done. You have a percent model now. Okay, now we're going to use that model, so I better copy and paste it. I'm going to use that model. I want to find P of 25, and what does it mean? So I want P of 25, so that means I put 25 in the numerator and 25 in the denominator. So 25 here and 25 here. So I'm going to go grab a calculator to do that. And it's so helpful if you have the alpha F1 thing. You can N over D, numerator over denominator. Let me make this smaller so I can fit it all in there. So I want 437 times 25, close parentheses, minus 142. Then use your arrow key to get down. 1.30 times 25 plus 94.02. It looks just like you expect it to look. Right? That new feature with the numerator over denominator business that's only available on an 84 with the new operating system, that is. All right, and then let's see here. So I would say this is about 85. Oops. There we go. About 85 point, what was that? 85.23. Okay, now what does it mean? Well, t was time, and time was 25, right? So 25 years after our starter year, which would be, let's see, 2015. So the model predicts that in 2015, 85.23% of U.S. households will have internet connection. Beautiful. All right, now the next question is, when does the model predict that all households will have internet access? Use a graphical method. Okay, so first thing I'm going to do is I'm going to go in here, I'm going to clear this out, hit alpha F1, and I'm going to type in my expression. So one sec. There we go. So I hit the alpha F1 key, 437x minus 142 over 1.30x plus 94.02. And then I want to know when it's going to be equal to 100%, because that would be all of them, right? Then I'm going to go to my window, and I'm going to hit like 0 to, I don't know, 50. Let's see what happens. And then 0 to 120, because I have to make it higher than 100. I'll make each tick mark worth 10. And then I'm going to graph it. I'm going to cross my fingers, and I'm going to hope that it hits 100 on my screen somewhere. And there it does. So you hit calc, number 5. Yep, first curve. Yep, that's my second curve. So hit enter, enter, enter. And there it is, 31.08. And 1990 plus 31.08 is 2021. So that's the year, 2021. So the model predicts that all U.S. households will have internet access in 2021. And we're done.